everyone, today we're going to be exploring properties of parabolas, graphing quadratic functions in standard form, finding max and min values of quadratic functions, and graphing quadratic functions using x-intercepts. Last lesson we talked a lot about how to graph in standard form. It's a 5-step process. 1 was to identify the a, b, and c values. Number 2 was to find the axis of symmetry. We talked about how you have to memorize x equals negative b over 2a. Because the axis of symmetry runs through the vertex, once you know the x value of the axis of symmetry, then you automatically know the x value of the vertex. And once you get the x value of the vertex, you just have to plug in the x value back into your original function in order to get the y output of the vertex. Okay, once you get all of those components, then you're going to find your y-intercept. Remember, the y-intercept is just the c value on standard form. Anytime you want to find a y-intercept, you just plug in 0 for x and simplify, and that will give you the y-intercept. Okay, and then last but not least, the 5th step was to plot the mirror point for the y-intercept, just so that you can get an idea of the width of the graph. Today we're also going to talk about max and min values. So what is a maximum or minimum value? That is either the highest or lowest y value on the graph. The max or min value is the y value of the vertex. Remember, the vertex is the highest or lowest point on the graph. So it makes sense that we would look at the highest or lowest point on the graph in order to get the highest or lowest y value. Okay, if a quadratic function has a minimum value, then that means the U-shape is going to open up. Okay, that occurs when a is positive or greater than 0, and the parabola, like I already said, it's going to open up. You can see that a parabola that opens up has a minimum value. If you see that in the very front there's a negative sign, that means a vertical reflection has happened, and so it's going to cause the parabola to open down. Whenever we want a maximum value, we should expect the a value to be less than 0, so there's been a flip, and the parabola is going to open down. See how when the parabola opens down, how there's a maximum value? Right? Opens up, there's a minimum value, opens down, there's a maximum value. And that is the same concepts that are explained in these charts. Again, if a is bigger than 0, it opens up, and you can see how there's a minimum value. If a is less than 0, then you get a picture of a parabola that opens down, and there's a maximum value. This picture also just reviews how the axis of symmetry is x equals negative b over 2a, and it talks about how the function on the left goes from decreasing to increasing, and how the function on the right goes from increasing to decreasing. In example 1, we're going to work on finding the maximum or minimum value. To find the minimum or maximum value of the function, the first thing that we have to do is graph the function. Now, this function is written in standard form, so I'm going to use that 5-step process that we talked about last class. Remember, the first step is to identify your a, b, and c values. So just looking at this, I can see that my a value is 1/2. My b value is going to be -2. And my c value is going to be -1. The next thing I want to do is determine my axis of symmetry. I use x equals negative b over 2a for that. Okay, so axis of symmetry is x equals negative b over 2a. What is opposite of the b value? It would be +2, right? If I do minus a -2, then that's going to end up becoming a +2 in the numerator. Over 2a, and a here is 1/2. So what is that? That's going to simplify to 2 over 1. So my axis of symmetry is x equals 2. All right, graphing that, it's going to be a vertical line through the x value 2. All right, my next step is to find the vertex. Remember, to find the vertex, we use the same x value as the axis of symmetry. Okay, so for the vertex, it's also going to have an x value of 2. And then I just plug in 2 to my function to get the y output. F of 2 equals 1/2 2 squared minus 2 times 2 minus 1. Simplifying this, I want to make sure I take care of the exponent first, so that'd be half of 4. And we have minus 4 minus 1. Half of 4 is 2. So what is 2 minus 4 minus 1? That would end up being -3. Okay, is it going to be a min point or a max point? Well, in this case, the a value, because it is 1/2, it's a number that's greater than 0. There's been no vertical reflection. So because the parabola opens up, that means that there's going to be a min point. And if there's a min point, then there's also going to be a min value. Remember, a min value is just the y value of your vertex. So we'll have a minimum value at -3. Okay, so we're done with the vertex. What comes next? The y-intercept. That's where we plug in 0 for x and simplify. We should just be left with the c value. All right, so here, if I want the y-intercept, I would plug in 0 for x. So I'd have 1/2 times 0 squared minus 2 times 0 minus 1. 0 squared is 0, times 1/2 is 0, 2 times 0 is 0. So you can see I'm just left with that 0, -1. And -1 was the c value. Okay, let's go ahead and graph what I have. I've got a vertex at 2, -3. I've got a axis of symmetry that I've already graphed. I have a y-intercept at 0, -1. Okay, and remember, after you've got the y-intercept, go ahead and plot the mirror point in order to get the width of the graph. So if I mirror that point, it's a distance of 2 away from the axis of symmetry. So I'm going to graph it right here. We can connect those points into a nice U-shaped graph. Okay, if you ever want additional points, just feel free to use your graphing calculator. Let me show you what I mean by that really quick. I'm just turning it on, and I'm going to go to the y equals button right here. And we want to enter in the function that we were working with. Okay, so I'm going to do parentheses, 1 divided by 2, close parentheses, x squared. Arrow over, we have minus 2x. And arrow over, let's see, minus 1. Okay, once you have your function typed in, you're going to press graph. If your graph doesn't look like mine, like if you don't see the function at all, or if your x and y axis are messed up, just go back to a zoom standard. If you click on zoom and go down to number 6 and press enter, that should get your x and y axis to match mine. Okay, and that looks pretty good. That looks like the graph that we had built. Like if I go back here, doesn't that look very similar to our graph? Okay, if you want other points to plot, you can go into your table. Do you see how there's the word table in blue here? Just have to go to second, graph. And then we have a table of points. So some easy points would be to graph -2, 5. 0, -1, I think is already on our graph. 2, -3. We'll have to see if that's on our graph. 4, -1. Just off to the side, I'm jotting these points down so I can test them. So again, -2, 5 will check. 0, -1 will check. 2, -3 will check. And 4, -1 is pretty easy to graph. Okay, so let me go back Okay, the ones we wanted to check were negative 2, 5, negative 2, 1, 2, 3, 4, 5. So that point is right there. So we made our graph a little bit too narrow. So I'm going to revise that just a hair. That looks better. Okay, there's the point negative 2, 5. We should see 0, negative 1, which we do see. We should see the point 2, negative 3, which remember that was the vertex or the minimum point. And then we have 4, negative 1 right here. So all that is looking good. I see all of those points. Now let's determine the domain and range. Remember, domain are the x values that you use on your graph, and range, those are the y values. For parabolas, there's never going to be any restrictions on what x values that you can use. Okay, so all real numbers is what we'll put for domain. Range does have some restriction. Do you see how we noted that the minimum value here was negative 3? That's important to note. Okay, if the minimum value is negative 3, that means that your y values are going to either be greater than negative 3 or equal to negative 3. Right? This is the lowest point. There are no y values that are lower than negative 3. It can only go up from there. Okay, now let's talk about increasing or decreasing. When we're talking about increasing or decreasing, we want to move from the left to the right. I'm going to put a person here on the left. If you move left to right, they would have to go down the roller coaster till they reach the very bottom. And then once they reach that axis of symmetry or the lowest point, then they would work their way back up the hill. This side where they're going down would be decreasing, and this side where they're going up the hill would be increasing. So I would say that it's increasing to the right of the vertex or the axis of symmetry. Okay, and I'm going to intentionally choose axis of symmetry and put the equation of the axis of symmetry there just for consistency purposes. That's what we're always going to use. We're going to say it's increasing to the right of the axis of symmetry, and we're going to say that it's decreasing to the left of the axis of symmetry, which again is x equals 2. Let's try this again with the student practice. It says find the minimum or maximum value of negative x squared plus 5x plus 9. I like that this example has a negative out front because it'll be a different type of example than the last problem. In the last problem, the parabola was opening up, and immediately once I see that negative out front, I know there's been a vertical reflection and the parabola is going to open down. Okay, so again, let's go through the 5 steps for standard form. I'm first going to identify A, B, and C, and then use that to find the axis of symmetry. Okay. So here it looks like my A value is negative 1, my B value is 5, and my C value is 9. Okay, again, the axis of symmetry is x equals negative b over 2a. Opposite of the b value would be negative 5, and the a value was negative 1. So we end up getting negative 5 over negative 2, which reduces to positive 5 halves. Because we're going to be graphing it, instead of putting x equals 5 halves is equivalent to 2.5. So I'm going to put that instead. Alright, moving on from there, now I find my vertex. The x value of my vertex is going to be 2.5, and if I want to find my y output, I just have to plug in 2.5. So h of 2.5 is going to be equal to negative 2.5 squared plus 5 times 2.5 plus 9. Okay, and I'm just going to type that all into my calculator. Negative parenthesis 2.5 squared plus 5 times 2.5 plus 9. Okay, and if you want to see what I put in my calculator, this is what it looks like. And I get 15.25. And that's an exact number. That's not rounded. Okay, so I put 15.25. Again, because A was less than 0, I know that my parabola is going to be opening down since it's been vertically reflected. So that means that this is going to end up being a maximum point. I already know that before I even graph it, which means that we're going to have a maximum value of 15.25. Okay, that is going to end up being the highest y value on my graph. If I want to find my y-intercept, I know it's going to be 0, comma, some number. In this case, my c value is 9, so it's going to be 0, 9. Okay, so let's graph that. My vertex is 2.5, 15.25. Oh boy. I think this is only a 10 by 10 graph. So for the y-axis, let's go ahead and go up by 2s. So on the y-axis, I'm going to make this go up by 2. So it'll be 2, 4, 6, 8, 10, 12, 14, 16. And that should work for us. The x values, I'm still going to have just change by 1. All right, so we have 2.5 and then 15.25, so that'll be around here. And then I've got an axis of symmetry through x equals 2.5. I have a y-intercept at 0, 9, so that'll be right here. And then I'm going to mirror that point. This is a distance of 1, 2.5 away from the y-axis. So I also want to go a distance of 2.5 away on the other side of the axis of symmetry. 1, 2.5. Yep, that looks good. All right, and then we connect those points and create our nice U shape. Okay, again, if you want extra points to plot, just go into your table of your calculator. All right, in this case, the domain, again, is always all real numbers. The range is impacted by the y value. Remember, your maximum value was 15.25. Because that is your maximum value, what that means is that there's going to be no points above it. So my y values are either equal to 15.25 or they're going to be less than 15.25. Okay? For increasing and decreasing, we're going to work our way from left to right. Put your person on the left side of the graph and think about what they'd have to do first. They'd have to go up the hill, so that would be increasing, until they got to the axis of symmetry. And then once they got to the axis of symmetry, then they'd have to go down the hill, so that would be decreasing. So I'm going to say it's increasing to the left of the axis of symmetry, and the axis of symmetry is x equals 2.5. And it's going to be decreasing to the right of the axis of symmetry, x equals 2.5. Okay, so that wraps up our standard form. Now we're going to get into something called intercept form. Intercept form deals directly with the x-intercepts. It says when the graph of the quadratic function has at least one x-intercept, the function can be written in intercept form. And this is what intercept form looks like. It's a x minus p, x minus q, where a is not 0. Okay, p is an x-intercept, and q is an x-intercept. Okay, so if I look at this graph here, here's your x-intercept p comma 0, here's your x-intercept q comma 0. And you can see that directly in between those two x-intercepts, we'll have the axis of symmetry. Okay, so normally we can just count to figure out what's right in the middle of those two x-intercepts. But if you would like an equation, you're just averaging those two values. So if you add them up and divide them by 2, the average of those two values will get you the x value right in the middle. Let's take a second and talk about why p and q represent the x-intercepts. Answer this question for me. How do you find an x-intercept? What do? You plug in 0 for y, right? So let's imagine doing that. I'm going to take this y equals equation and I'm going to plug in 0 for y. We would end up with 0 equals a, x minus p, x minus q. Now notice all of those components are being multiplied together. A is being multiplied by x minus p, and x minus p is being multiplied by x minus q. How do I get a product that's equal to 0? Well, in order to get 0 from a multiplication problem, one of those factors have to be 0. Either a is equal to 0, right? Because if a was equal to 0, then we would have 0 times x minus p times x minus q, and that would end up getting you 0 when you multiply that out, right? 0 times anything would just be 0. Another option would be that x minus p is equal to 0, right? Because if x minus p was equal to 0, then it would look something like this. And again, 0 times anything is just 0. The last option that we have is that x minus q would be equal to 0. And if x minus q is equal to 0, it would look something like this. And again, 0 times anything is just 0. Okay, so with those three options, and knowing that a can't be 0, so that's off the table, that leaves me with either x minus p has to be equal to 0 or x minus q equals 0. Well, if I want to finish solving for the x-intercepts, here if I add p to both sides, I would get that one x-intercept is p. Or here, if I take x minus q equals 0 and add q to both sides, I get that x equals q. All right, so those are your x-intercepts. Again, how do we find the x-intercepts? We plugged in 0 for y and tried to solve for x. So x would equal p or x would equal q. All right, so let's try that in example 2. It says graph -2 times x plus 3 times x minus 1. Label the x-intercepts, axis of symmetry, and vertex. Okay, so let's first find the x-intercepts. How do you find x-intercepts? You plug in 0 for y, right? So that's what I'm going to do, is I'm going to plug in 0 over here for y. We would get 0 equals -2, x plus 3, x minus 1. Again, based on that property, in order to get something that multiplies to give you 0, either -2 is 0, which that's not true, or we could say that x plus 3 has to be 0, right? If this was 0, 0 times anything would just be 0. Or another option would be that x minus 1 has to be 0, right? Again, because if this was 0, 0 times anything would just be 0. Right, solving for x, here I would subtract 3 on both sides. So we get -3 is equal to x. And here I would add 1 on both sides, so I get that 1 is equal to x. So I get that the x-intercepts are -3, 0, and 1, 0. Okay, a really quick way to find those is it's really the opposite of what is written here, right? +3 looks like it became -3. -1 looks like it became +1. That's just a quick trick, okay? But remember, anything inside parentheses is typically opposite of what you think. Let's go ahead and graph that, -3, 0, and 1, 0. The axis of symmetry is going to be smack dab in the middle. So it looks like the axis of symmetry would be right here, right? A distance of 2 away from each point. So I must make the axis of symmetry x equals -1. And then remember, the vertex is going to lie on the axis of symmetry. So I already know the x value of my vertex. How do I get the y value of my vertex? Well, I just have to plug it into my function, right? What is f of -1 equal to? We'd have -2 times -1 plus 3 times -1 minus 1. So I'd get -2 times 2 times -2. So that'd be -4 times -2, so that should be 8. -1, 8 would be the vertex. Okay, and let's go ahead and graph that. -1, 8 will be up here. Okay, and there you go, you get your parabola. Perfect. Okay, so to graph a function in intercept form, you'll notice we followed these steps. First, we found the x-intercepts. Remember, x-intercepts are just your p and q values. Really, if you look at the function, though, it's almost opposite of what you think. Like if you saw a +3, it became -3. If you saw a -1, it became +1. Kind of weird. Once we got the x-intercepts, we look smack dab in the middle to get the axis of symmetry. Axis of symmetry is in the middle of those x-intercepts. Okay, and then once we got the axis of symmetry, that gave us the x value of the vertex, the x value from axis of symmetry, and then we'll plug it back in order to get the y value. Okay, if you want to check your work, you can generate a table on your graphing calculator. So just in my y equals, I'm going to go ahead and put in this function, -2 times x plus 3 times x minus 1. I'll show you what that looks like. I'm going to hit graph to check my work. It does look like the graph I got. Let's go ahead and go into a table, second table. Here's some points I could have plotted. -4, -10. I'm just going to make a note of this. -4, -10. I'm going to make a note of -3, 0. I'm going to make a note of -2, 6. I'm going to make a note of -1, 8, 0, 6, 1, 0, and 2, -10. And those are really all the ones that'll fit on our graph. So let me go back and see if I have all of those points. -4, -10 would be right here. So we could actually make our graph just a hair wider than what it was before. So I'm going to make sure it goes through that point right there. Okay, I should have the point -3, 0, which I already do. That's right here. I should have the point -2, 6. 1, 2, 3, 4, 5, 6. Yep, there it is. Okay, I should have the point -1, 8, which that was our vertex. Okay, I should have the point 0, 6. 1, 2, 3, 4, 5, 6. That's right here. I should have the point 1, 0, which I already had plotted as my x-intercept, and then 2, -10. So this point all the way down here. Okay, so that looks good. Just a couple more student practice examples, labeling the x-intercepts, axis of symmetry, and vertex. Okay, for the first one, to find the x-intercept, remember we plug in 0 for y and try to solve for x. In order to get a product equal to 0, x plus 1 is either going to equal 0 or x plus 5 is going to equal 0. Right? 0 times x plus 5 would be 0. Or if I got 0 here, then 0 times, again, anything would just be 0. All right, solve for x. Here I'll subtract 1 on both sides. X is -1. Here I subtract 5 on both sides. X is -5. So I get the x-intercepts -1, 0 and -5, 0. All right, just to check your work, should look like it's opposite of what was inside these parentheses. Okay. Once I have the x-intercepts and I plot them, I can look smack dab in the middle for the axis of symmetry, so it's going to be right here. It looks like the axis of symmetry is at -1, 2, 3. Okay. Another way that you can quickly find the axis of symmetry is you can just add together the two x values and divide by 2. You can see how -6 divided by 2 would also give you -3. And then the vertex, because it lies on the axis of symmetry, is going to have that same x value. and if I plug it into my function, then I can find the y output. So if I plug it into my function, I would have negative 3 plus 1, negative 3 plus 5. So I'd end up getting negative times negative 2 times positive 2. So I would get, that would end up being positive 2 times 2, which is 4. Okay, so I would graph negative 3, 1, 2, 3, 4. Okay, again, if you want additional points, you're welcome to plot that on your graphing calculator just to make sure that all of your ordered pairs that you've graphed are correct. And I would definitely make sure that your vertex that you put down appears in your table. Okay. Same thing over here. Let's start with x-intercepts. Remember, in order to get an x-intercept, we plug in 0 for y and we try to solve for x. In order to get a product that's equal to 0, one of these factors have to be 0. Either x minus 6 is 0 to get a product of 0, or x minus 2 is 0 to get a product of 0. So I'm going to write that down. Either x minus 6 is equal to 0 or x minus 2 is equal to 0. Here if I add 6 on both sides, I get that x is 6. Here if I add 2 on both sides, we get that x is 2. So my x-intercepts have to be 6, 0 and 2, 0. Check your work. It should be opposite of what was inside the parentheses there. All right, axis of symmetry. I first have to graph those intercepts. 1, 2, 3, 4, 5, 6, and 2. Axis of symmetry should be smack dab in the middle. So it looks like the axis of symmetry is at x equals 4. Quick way to get the axis of symmetry is just to average your two x-intercepts, add them together and divide by 2. See how you still would get 4. Okay, for vertex, we're going to use that same x value since the vertex lies on the axis of symmetry. And I'm going to plug 4 into my function. So f of 4 would be equal to 1/4, 4 minus 6, and 4 minus 2. So I would get 1/4 times negative 2 times 2. So this would end up being negative 2/4 times 2, or negative 4/4. So that reduces down to negative 1. Okay, so for negative 1, that's what I get there. And I can go ahead and connect those points in order to get my graph. Okay, again, if you want extra points, go ahead and just put it on your graph, put it in your graphing calculator in y equals. I would especially do this to make sure that you got the correct vertex. Okay, so that's what I'm doing right now, just to make sure that my vertex is correct. My vertex should be at, what do we find? 4, negative 1, and we do have the point 4, negative 1. If you want a challenge, go ahead and take a look at my note videos for example 3 and the student practice. It gives you some real world scenarios of where you might see quadratic functions show up.